Welcome to the first episode of Optimal Solar Roofing. I am Jeff Adams. Through a great deal of research, design, and testing, I have cracked the code for affordable solar roofing. The approach I'm about to describe satisfies multiple budget levels. It also reduces risk. This is what success looks like. This is my test solar roof. The design is meant to replicate a real solar roof along with backing electronics. In case anyone is wondering, it isn't connected to anything except Wi-Fi and earth ground. These are CertainTeed Solstice solar shingles. They look great. I call them super shingles. From a distance, they look like a skylight, not solar panels. These best-in-class solar shingles are the actual covering on a residential roof. They have a 25-year workmanship and solar generation warranty. After working with them for several months, I don't see them ever physically wearing out. They are rated at class 3 out of 4 for impacts, which is a 1 3/4 still ball at 72 miles an hour. This property is on a golf course, so this is a great feature. Weighing in at 13 pounds each, they do not normally require any roof reinforcement. This is a 1 column by 10 shingle example. With roof space permitting, multiple sets of up to 60 solar shingles are possible with my design. Columns are the norm, but different shapes are possible. On my roof, I plan to also use spaces where conventional solar tech simply wouldn't fit. This will allow my system to generate more power. The first design innovation is invisible in this view. What you are viewing is 5 solar shingles wired as a set. On this test roof, this is 2 sets of 5. Notice how 5 solar shingles are approximately the same size as a modern solar panel? This will be important when I go through power output comparisons later in the video series. As a preview, they are close to being equivalent when actual solar generation areas are compared. On my test roof surrounding the solar shingles are heat-reflecting CertainTeed Solaris asphalt shingles. Other shingle styles are or soon will be available. And check this out. All the wires connecting the solar shingles to each other and the backing electronics are hidden and protected by the solar shingles themselves. This happens in the air gap underneath, which also helps keep them cool. Do you notice any roof penetrations? Neither do I. The single roof penetration for this column is sealed and covered, not once or twice. It's covered 4 times by the cascade of underlayment, trim, and asphalt shingles. CertainTeed has been in business since 1904. They have clearly demonstrated long-term staying power. Next to the test roof is a SilFab Elite solar panel. These are rated class 2 out of 4 for impact resistance. This impact resistance is obviously less than the solar shingles. With optimal solar roofing, only solar shingles are installed on the roof surfaces. Solar panels are installed on gazebos, pergolas, carport covers, or freestanding mounts. This design approach focuses on long-term roof reliability, minimizing costs, and generating large amounts of power. On the back side of the test roof is an Underwriter's Laboratory or UL rated metal box I sourced from Polycase. This box is also National Electrical Manufacturers Association or NEMA rated for outdoor use. The metal box houses best-in-class Enphase IQ8 or later microinverters, which also have a 25-year warranty. Microinverters convert the direct current or DC electricity produced by solar shingles or solar panels to alternating current or AC electricity used in the home or business. Each microinverter has a DC and an AC connection. It is much safer, less costly, and more reliable to convert from DC to AC as soon as possible via microinverters as opposed to the legacy approach I will cover in a few minutes. Enphase is a publicly traded company that has been making microinverters since 2006. Up to 4 microinverters can be installed and wired together in a metal box of this size. There will be one of these metal boxes for each column of solar shingles. The number 1 on this box indicates it is supporting column number 1. The metal boxes would be hidden in an attic space or hidden in a vaulted ceiling area by adding a false ceiling with furnace air return vents acting as access ports. I came up with this novel mounting and wiring setup for the Enphase microinverters in the metal boxes to allow their use with CertainTeed solar shingles. This is a key innovation, as normally solar shingles and microinverters do not work together because of available space. The metal boxes provide the space required by the microinverters as well as the DC and AC wiring. Speaking of wiring, each set of 5 solar shingles is connected to a single microinverter at its DC connection via 2 photovoltaic-rated 10-gauge wires made by Southwire, better known by the Romex brand. Extremely safe industry-standard MC4 connectors from Stoibli are used on these photovoltaic rated wires for the DC connections. Next, we see additional N-phase components, a combiner and the shutoff switch. Unlike on the test roof, these components would normally be installed in a garage near the main breaker panel and electric meter. The combiner is used to connect the AC output of all the microinverters in all the metal boxes to a residential breaker panel and adjacent utility power grid. The AC connection between the metal boxes and the combiner would be via 10-gauge Armor Light wiring, also from Southwire. Armor Light provides the extra protection required for these wires. Please be aware the combiner is not a single point of failure. It is simply a physical interconnection junction for the power-generating microinverter circuits. It uses the same passive design as a breaker panel, which is extremely reliable. The shutoff switch is used to turn the N-phase system off and on. By the way, you might want to show this setup to your kids. Seeing sunlight produce electricity is likely the closest thing to magic many will experience, but it's just science and engineering at work. This test roof is an almost complete configuration. The missing item is a battery. There simply wasn't room. That said, a key design philosophy of optimal solar roofing is that you can hit the pause button many places along the way to a complete configuration. For example, one could pause only after installing the solar shingles. The approach is to accommodate almost any budget by allowing time phasing of purchases. I will cover this in great detail throughout the series of videos. I need to be very clear on 4 important topics. Number 1, this unique configuration is as described in manufacturer documentation and thus does not violate National Electric Code or NEC in the United States. It is critical to meet national and local codes. Meeting code is also critical in maintaining homeowners insurance. For the solar shingles, this is straightforward. They were always going to be connected to the backing electronics via wires placed in a metal conduit eventually connected to an inverter. This is exactly the design followed by optimal solar roofing. For the N-phase microinverters, as you can see from the installation instruction, my design meets all of their requirements as well. The metal box is the junction box specified. I even included solar panel mini rails in the design for the microinverter mounting to meet the requirements. Number 2, this configuration is intended to be used worldwide with appropriate modification for localized requirements and building codes. Number 3, there is no cost for this information. I do not have anything for sale. I am simply sharing what I have learned in my design concepts to tie all of the components together. And number 4, at the time of this recording, I have no financial interest or ownership in the companies presented. I might own mutual funds that include them, but I have not yet. Other than CertainTeed sending me factory second solar shingles after I inquired how to purchase them, I have paid for everything you see in the test system. You're probably asking your first questions. Who is this guy, and why should I listen to him? I am a degreed electrical engineer from the University of Southern California. I have a background in aerospace and defense, manufacturing, software development, databases, and machine learning. I have been a founder and executive of multiple venture-backed Silicon Valley startups. I am an author and co-author of multiple patents on pattern recognition via machine learning. I'm also a certified N-phase installer. I had to become N-phase certified to configure this test system and place it into operation. Before I brief you on the 8 requirements that led to this unique design, it is important for you to understand why I had to undertake this next generation design, prototyping, and testing effort. It's pretty simple. At this property, I need a new roof before I can finish the exterior remodel. Given my current high electricity costs, which will only be going up in future years, I determined I needed to add solar generation capabilities to my new roof to at least zero out my electricity costs. I began researching and checking with people I trust about which equipment types, which manufacturers, and which installers to choose. During the process, I learned many residential customers are happy with their solar installations. Unfortunately, I was also briefed on a significant number of solar installations that had become nightmares due to installer, equipment, manufacturer delay, or runaway cost issues. A painting contractor relayed a horror story where his solar installation purchase price was refunded and he was reimbursed $50,000 because of the installer causing damage to his home. Ouch! A recurring theme was the mismatch between solar panel roof mounting requirements and residential roof reliability requirements. I also learned about high equipment failure rates, replacement delays, and inflated construction costs due to safety issues with legacy products called string inverters. It turns out they're also a single point of failure. Costs were a big mess. Quotes were all over the place. Many of the installation companies with which I interacted gave me a really bad feeling. They would not even respond to basic pricing questions. Most came across as quick buck artists not really concerned about doing a good job or building a relationship with me. Upfront costs were large with minimal opportunity to spread purchases and associated costs out over time. It is no wonder so many of these installation companies have or are going out of business. Deeper cost analysis showed the labor to install solar panels on the roof is the key driver of the high costs associated with solar installations. Poor documentation, non-responsive, and overseas support added to the tribulations of many existing customers. Lastly, I learned about permitting delays, utility interconnection delays, and utility power buyback issues. With all the information I gathered, there was no way I was going to engage with the solar installation industry as is. Something had to change before I would pull the trigger to install solar on my roof. I looked for solutions to the problems I encountered. Bits and pieces existed. However, there was no reliable, integrated, and cost-effective solution to the problems I had uncovered. A one-stop shop that solved all of the problems simply did not exist. A short while later, I came up with the 8 requirements for a complete and integrated solution. Interactions with key professors at USC and mentors has taught me those with the ability to conceive of a solution to a pressing problem have a responsibility to design and build that solution. That's what engineers do. With that mindset firmly in place, I acquired the components and started building the prototype. Once the prototype was complete and working, I realized I had to share it with others. After seeing the prototype in action, I truly believe this approach has the potential to make a significant impact on how the world consumes electricity. When optimal solar roofing becomes successful, many great jobs will be created in the manufacturing, roof contracting, and electrical contracting professions. To mitigate the affordability issues I uncovered, I have focused on making optimal solar roofing affordable for nearly everyone with novel design choices, financing approaches, tax credits, potential time phasing of purchases and installations. In this video series, I will show you how to construct and benefit from the solution I devised. I did all the research, legwork, design, and testing so you don't have to. Please subscribe to be kept up to date as I release additional videos. I expect to have many questions posed based on my unique and guaranteed to be controversial approach. I will do my best to answer all of your thoughtful questions. Thank you.